Hello everyone. In this video, we will talk about standard form in exponents. Remember, we spoke about equivalent fractions. So when I have 2 upon 3 and I wanted to show this as something upon 9. So I wanted to change the form of this fraction but not the value. So in equivalent fraction, we change the form. The fraction looks different, but the value of the fraction does not change. So to change 3 to 9, I have to multiply 3 by 3. So to ensure that value does not change, I will multiply the numerator also by 3. And then I get 6 upon 9. And now we called 2 upon 3 and 6 upon 9 as equivalent fraction. So in equivalent fraction, what happens? The form, the way it looks, the fraction is different because it is 2 upon 3, it is 6 upon 9. It looks different, but if you look carefully, we know that the value is same. The value is same. Similar thing we are going to do with the exponents as well. So we have, let's say, one exponent 237.54. Now I want to show this exponent in different form where the decimal point should be after one digit only, one whole. So I want to show this as 2.3754. So what actually I am doing? I am moving this decimal point 2 places and putting it here. I am moving this decimal 2 places. And if you compare, this new number is smaller than this number. It is 237.54 and this is 2.3754. How much it is smaller? It is smaller by 100 times because we have moved the decimal point 2 places. Each place is we multiply by 10. So we have, this is 100 times smaller than this. So if I do 237.54, if I divide this by 100, I get 2.3754. So that means I have divided this number by 100. But to keep the value same, what should I do? I should multiply this number by 100. So to ensure that these are same, these are equal, I should multiply this number by 100. I have divided by 100 and I multiply also by 100. So that the value does not change. And this 100 I can write as 100 is same as 10 raised to 2. And that's my exponent form. And this is called the standard form of exponent. So what we do in standard form of exponent, important thing is the decimal point has to be after one digit, always after one digit. And based on shifting of the decimal point, we need to also adjust the multiplier, which is 10's power, exponent of 10. Let's take some examples to understand this better. So I have this exponent and I want to show this in standard form. So I'll write 2.3742 into 10 raised to 5 because that is there. So I'll keep that as it is first. But this is not same value because here to move these 2 places I have divided by 100. So I need to multiply this by 100. But we know 100 is 10 raised to 2. 100 is 10 raised to 2. So it will be We see same base 10. So what we can do? We can add the powers. Keep the base same and add the powers. 5 plus 2, 7. And this becomes the standard form of this. Let's take one more example. I have this number 0.523 into 10 raised to 19 and I want to convert this into standard form. What is the first requirement? The decimal point should be after one digit. 0 is not counted here. So it should be 5.23. So what I have done? I have shifted this to right. To shift this to right, I have multiplied by 10. To shift this to the right, I have multiplied by 10. So I need to now divide by 10. And if you see here, 5.23 into 10 raised to 9 divided by 10. Same base. So the base remains same. And division, so subtraction of the powers. When it is 10, nothing here, it is 1 here. So it will be 9 minus 1. And the answer would be 5.23 multiplied by 10 raised to, sorry, it was 19 here, 19 here, 19 minus 1 is 18. Let's now put this in a method. So this is a concept, but let's now put it in a method to make it very easy. But you must follow the method, there is no doubt about it, but the students should also understand the concept. Why is this happening? Okay, so let's do that. We'll convert this into standard form. In that case, very simple, write the number, just shift the decimal point. How many places you have shifted? You have shifted 2 places to the left. You have made the number smaller. This was 112. This has become smaller. When this becomes smaller, we have to increase the power by the places you moved. 2 places, so increase the power by 2. So it was 5 here, make it 7. Increase it by 2. Let's say I have this 0.932 into 10 raised to 6. First step, just write it 9.32 into 10. Now we have shifted this to the right, which means we have the number is increased. So if the number is increased, the power should be reduced. By how much? The number is increased by 1 0. We have moved 1 place. So the power should reduce by 1. So 6 minus 1 is 5. So if you see here, if the original number and the new number, if the new number is reduced, it's smaller than original, new number is reduced, then power increases. If the new number is increased, here 0.9 and here 9 point something, so it is increased, then the power reduces. The reduction or increment depends upon how many places you have moved the decimal point. Here we have moved the decimal point 2 places. So we increment it by 2. Here we have moved by 1 place. So if we have to reduce, we reduce by 1 the power. Let's take one more example. Let's represent this number in standard form. So now when we have a whole, we know that there is a decimal point here. That's hidden, but it is here. So if I have to move decimal point, I have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 places. So that I have this 3.0804 and then 6 zeros. 1, 2, 3, 4, 5, 6. So I have moved 10 places. So remember 10 places. Now this number is bigger and this is smaller. So number has become smaller, so the power has to increase. What was the power here? There was no power. So the new power has to be increased by 10 places. So 10 raised to 10. Now these zeros towards the extreme right of the decimal point, the zeros which are extreme right of the decimal points have no values. So this can become 0804 into 10 raised to 10. Let's take one more example. If I have this, I have to represent in standard form. What I will do first, I will put 4.249, and I will not write the zeros. Extreme zeros I will not write. How many places I have moved? 1, 2, 3, 4, 5, 6, 7. 7 places I have moved. So this number is big, this is small. So it has become smaller, so the power has to increase. By how many? 7. There is no power here, which means it is 10 raised to 0. So now if we have to increase by 7, 0 plus 7 is 7. So 10 raised to 7. So this is my answer, standard form. I am sure you have liked the video. Hit the like button and leave your views in the comment section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the YouTube app at the link provided in the video description. Till we meet again, goodbye.